Swayam Prabha. Digital India. Educated India.
Okay, good day and welcome back to this class. Today we will discuss site selection. Nobody wants a landfill in his backyard. If I come to your house and say next to it, I want to make a garbage dump. So will you agree? He will not agree. Because he will say, I'll get a bad smell from this all the time, and flies and all kinds of pests and infections and hazardous fumes. So nobody wants a landfill near his or her area. It's called the NIMBY effect, not in my backyard. So the biggest problem is to find sites which are acceptable to people for making landfills. And the current state of the art in India is that if you have an old waste dump, where people are already used to the fact that waste comes, then a site adjacent to it or remanaging the same site to create a larger landfill is very easy. But you go to a pristine new site where people are close by, then it's very difficult to acquire that land and allow the local population will not allow you to make the landfill. However, if you have degraded land, something which was polluted by an industry in the past, or something which has no use, saline, there is no agriculture, you can't make any industry on it, then degraded land can also be, degraded remote land can also be used for landfill sites. So site selection is a process which first allows you to identify which sites can probably be used for putting your waste, and then amongst the sites, which site is the best or which site is the one which you should adopt. So site selection involves the following steps. You should have an idea of the size of the landfill that you need. You are going to have a landfill for 15 years, 25 years. So what is the size? What kind of area are you looking for? What is the quantity of waste? We have already done this. Then around the city or the urban center where you are going to make the landfill, do constraint mapping. What is constraint mapping? Constraint mapping is, these are all constraints. If you have a pond or a lake, you can't have a landfill. If you have a river, you can't have a landfill 100 meters. If you have a highway, you can't have a landfill 500 meters. So if you know all these locations around your urban center, then you can make these huge circles saying, these are the buffer zones, I can't put a landfill here. So undertake constraint mapping. After the constraint mapping is done, there will be some sites which will emerge. Whether these are available or not, but there will be some sites which will emerge. So they become the potential sites. So we get a list of potential sites. You may get 2, 3, you may get 5 if you are very lucky, you may get 1 if you are unlucky, you may get none. if you are living in a place like Delhi where every place is populated, there is a community or habitat, you start making circles of 500 meters around the habitated area, you may not have any landfill site left. If you have got sites, then you will do preliminary data collection. You will do preliminary data collection, you will do site walkover on each of these sites, you will do a site investigation to get some additional data, then you will do a ranking of the sites. And the site which scores the best marks in terms of acceptability should be adopted. You will have to go for a public consultative process, which is the one which has a big issue, because the moment you do a public consultation, you are involving the local people about its the landfill, and public acceptance is a major issue, and then you have to get your regulatory approval. So this is a locational criteria which we had discussed in the beginning. This is of course changing from time to time. The new rules, I will tell you, the 2016 rules have a slightly different criteria, but this is a good one. This is a good one to follow. Now I am going to show you a work which was done by Mohit in his MTech. He did constraint mapping for a landfill for Allahabad division, not Allahabad city, not Allahabad district. But I understand a division comprises of 3-4 districts. So the concept was nobody was willing to give land for a landfill. So they said, okay, everything will be far off from the city. Can we have one site where the waste from all these 4 districts can come? That's the concept of a regional landfill. Don't keep it close to your city. Don't try and reduce transportation costs, but make a huge dump somewhere remote where waste from different districts and cities can reach. So this is an exercise which they did for the and they used the GIS software, and they were able to identify 5 possible sites for the Allahabad division. So what did they do? Their constraint mapping criteria was different. We have different, but more or less, for example, they have added power lines. If you have a transmission line, you have to be 700 meters away from the transmission line. This is not in our. Using this criteria and using the distance approach, they actually got these topographical maps with population density for this entire division. There are many, at the center of all these circles are the major cities, and these circles represent the maximum distance to which the waste will be sent from these cities. So by overlapping these circles, and you've got 4 circles here, can you see that? They are able to identify a region where everybody can send their waste, right? And what is the diameter of this circle? 50 to 55 kilometers was the diameter of the circle. So everybody was willing to send their waste from the center till about 30 kilometers away. Let's look at this area now a little bit closely. When you look at the triangular area, and this diagram is not very clear, but there are some railway lines, there are some roads, there are some rivers, there are some water bodies, there are some transmission lines. Those are the ones which will require constraint mapping, and also there is habitation. So several of these dots which you can see indicate the population in that area. So for each of this, for example, if you have a road, what is our constraint for the road? How near can we be? 500 meters if you have a highway. So if there's a highway which is going through, you are going to lose 500 meters on either side. So when they put all the constraints, there was transmission line, there was road, so all these colors are the constraint mapping. River, road, all that remained were these brown portions. So the constraint mapping throws up areas which are not coming under any buffer zone of any of the things: a river, pond, transmission line, road, habitation. Those are your 5 areas in that triangle which was acceptable to everybody. So now we have to find out which site to select. So they went ahead and looked at the areas which were available, and you can see that site 3 had probably the maximum area, followed by site 4. And so now I have 5 sites. I mean, this is 5 or 6 sites, sorry. And if I have to select within these sites, I have to do a site ranking. So I go to each of the site and start doing data collection so that I can then do site ranking. So I need the topographic maps. I will not have very fine contour interval maps, but I'll have some coarse topographical maps from the Survey of India. I can get aerial photography from the National Remote Sensing Agency, or now even Google Earth will give you some kinds of maps. We have soil maps of India, you would have heard about it, but as geotechnical engineers, I have never used a soil map. Why? Because the soil map is actually prepared for agricultural purposes. It is the surface soil map. So if somebody says, oh, this is the soil in this area, if you go 20 meters below, that's not the soil in that area. But if you want to grow a crop on it, then you can say, yes, yes, on the surface, on the top few inches or the top 1 meter, you'll have that soil. So you can go and get an idea of the soil from the soil maps, get the geological maps from the Geological Survey of India, groundwater maps, at least you'll get an idea where the groundwater table is. Seismic, zone 1, 2, 3, 4, you'll get from IMD or even the code. You need rainfall data. Is it a high rainfall? Is it flood prone? Is it low lying? So you can get that from the Indian Meteorological Department. I think floods will also come from Central Water Commission. You may have some data with the Central Water Commission about the floods. And wind, solar data, evapotranspiration from IMD. Get this data for all the 5 sites. And then do a site walkover. And when you go to a site, what do you want to go and see there first? Is it a flat ground? Is it sloping? Is it low-lying? Is it undulating? Is it hilly? Is it a valley or any other? So once you will go to a site, you will get that immediate feeling. Then on your site walkover with the topographical map, you can say, okay, this is what it looks like. See, site walking is ground truthing. Some of the maps which you will see may have been old. Even the Google Earth photograph sometimes is how many months old? If you go to Google Earth, don't think you are seeing today's photograph. Do you think you are seeing today's photograph on Google Earth? No. When you see terrain, there will be several months or a couple of years old. If you are the professional user, you will be able to pay and get the latest photographs for that area. Look at the current land use. Is it if it was irrigated cropland, it will go away in the buffer. But is it forest land? Is it wasteland? What kind of land is it? The simplest to do is to find out about the groundwater table. Is there a well nearby? And look at the water depth. And depth of bedrock comes from tube wells. Sometimes your well may not be reaching the bedrock, but a tube well is taking out water from say 150 meters. He would normally tell you that 150 meters ke pehle, are we taking out the water from a weathered rock or are we taking out the water from soil? So you get information on bedrock. How close is the nearest building? Is there a village nearby? Habitat? What kind of population is there in the 500 meter diameter buffer zone? Is there availability or there is no buffer zone? Actually, it should not throw up because you have done constrained mapping. But still, you would like to, somebody might have taken the census of that area 5 years ago. You would like to have a current situation. Distance to the nearby road, distance to the nearby river or a lake or a pond. This is all from site walkover. Surface water drainage. Is it a well-drained site or is there water logging? You can find out. Are any drains, pakka drains passing through that area? The moment you have drain, there's a constraint. The moment you have a transmission line tower, there's a constraint. The moment you have underground utilities, some pipe is passing. You will not be able to put your landfill on that pipe. So if it's an underground sewer line, you will not be allowed, or the water main for a city, you will not be allowed. So identify all this. If the bedrock is exposed, have a look at it. If there are some ponds, report it. Is it marshy land? Is it why it's lying empty, that nobody is using it? Marshy land normally means water table is high. So you will have those issues with that. Are there any mining or deep pits? Any obstructions? And what is the natural vegetation? Is it arid? Is it shrubbery? Or is it densely vegetative? All this comes from the site walkover. In addition to that, you have to do some site investigation. Now you have the topographical map from the Survey of India, but the contour intervals, I don't know what contour intervals did you get for the Allahabad division, do you recall? Eventually for your design, you are going to need topographical map with contour intervals of 1 meter or half a meter. Right? And that's not what is going to be available to you from the Survey of India. It will be 10 meters or more. So do your topographical survey, at least drill 3 to 5 boreholes to understand what is below. Standing on the top, you cannot predict what is below. This 3 to 5 boreholes is only for the site selection. If you are going to do design, you will have to do 2 boreholes per hectare. So typically a landfill may require 10 to 15 boreholes for a detailed design. For depth to water table and fluctuations, look at 3 to 4 wells. If 2 are already available, look at the groundwater fluctuations. Check about the availability of clay and other materials. Look at background levels of gas, noise, dust. You are also going to look at background levels of surface water quality and background levels of groundwater quality. If the groundwater is already saline, then your site is better for you to use because you are not putting a landfill on top of a drinking water source. So you have to get this data and get an idea. All landfill sizes will not be the same. The land available will have different shapes, different sizes. So look at the costs and the capacities that can be accommodated. With this, you can go ahead for site selection. So after you've done your site investigation, you will now have an idea what's below. Before that, you had an idea what is on the top. And at least you should be able to say that there are 2 or 3 types of soils. It's clay, silty, sandy. Is there a bedrock? Is there a groundwater table? You should be able to say all that. That's about it. Once you are able to have that subsurface information with you, your site selection is so much easier. Now we have to have a methodology of ranking these 5 sites which we talked about. The Central Pollution Control Board in 2003 has come up with some guidelines, and this is one of the site ranking methodologies. If you go and look at literature, you will find other site ranking methodologies as well. So the Central Pollution Control Board says that there are 32 factors or attributes which have to be taken into account for ranking a site. 32. That's not small. And these are grouped into 7 categories. And let's say cost is a category, environmental impact is a category, distance is a category. So you've got 7 categories, and all those categories are given in weightage in a scale of 1000. So you may give more weightage to cost, somebody else may give more weightage to environment. So a group of experts, this is not done on whims and fancies. So by using the opinion of a group of experts, you come out of these weightages. We'll look at these 7 categories. But this 1000 may be divided up. If everything was equal, then it will be 1000 divided by 7. But everything is not equal in these categories, so different weightages arise. Within the category, now you have these 32 factors or attributes in 7 categories. So obviously each category has 5-6 attributes. To each attribute you have to give a weightage. So suppose one category had 200 points as the weightage, and within that there were 5 attributes, so you would have a tendency to give 40 to each, unless again a group of experts gives you a separate weightage. So once you have got the attribute, once you've got the weightage, the most important thing is a sensitivity index. So in this methodology, we use a sensitivity index between 0 to 1. If you have perfect impervious soil, sensitivity for groundwater contamination is 0. If you have horrible gravel, very high permeability soil, sensitivity for groundwater contamination is 1. So it's a scale of 0 to 1. If you know the permeabilities, you can give the sensitivity indices between 0 to 1. This is what CPCB has developed. You may or may not agree with it. You can do a critical analysis of it, but we will go through it. Now, once you have given the sensitivity for that site, you multiply it with the weight and you add everything. Right? And we'll just quickly look at it in the next slides. So you have an attribute. The attribute has a weight. It has a site sensitivity depending on the data coming in from that site. You multiply that sensitivity with that weight for that site, and for all the 32, you do this and you add them and you'll get a score. You'll get a score between 0 and 1000. The ideal perfect dream site is 0, and the most horrible site is 1000, because the worst case scenario is 1 site sensitivity index. So here are the categories and the weights which have been adopted by the Central Pollution Control Board. Something related to accessibility, receptor, who will receive, environmental aspects, groundwater, surface water, socio-economic aspects, waste management, large capacity, less capacity, climatology, high rainfall, low rainfall. If there is zero rainfall, then the sensitivity index will be 0. If you have Cherrapunji, sensitivity index will be 1. And geology related or subsurface related, what we call geotechnical, but what they call geology. If you add these all up, this will come to 1,000. Within the, for example, I talked about accessibility related 60 marks. There were 2 attributes: type of road passing nearby and distance from the collection point. So these are accessibility. So these are the weightages. This is 60. Receptor related, population, drinking water, nearest building, land use, property value, public utility, public acceptability. This is 250, and these are the breakups which are given. Environmental related, is it critical habitat, distance to surface water, not drinking water, surface water, distance to river, distance to groundwater, contamination possibility, quality of water, quality of air, quality of soil. If it's already degraded, then the impact is less. If everything is pristine and you go into a very nice sanctuary, then obviously your impact is going to be much higher. But if you go to a place where already the air is degraded, like Delhi, well, then you're making a lesser impact. That's not an example to take. Then socio-economic related health, will this whole waste to energy, waste to landfilling, will it create jobs? Will the odor have issues with the local population? You know, odor can lead to headaches, it can lead to depression. Is the visibility of that, is it going to be an issue? So 110. Waste management related, what will be the life of the site, right? And what is the waste quantity per day it will accommodate? 85. Climatology, how much precipitation? Precipitation effectiveness index is the ratio of precipitation to evaporation. In arid climate, it will be very low. In wet climate, it will be very high. Climatic factors contributing to air pollution, it is 15. And finally, the subsoil, where we geotech guys come in, the soil permeability, the depth to bedrock, erosion, characteristics of rock, is it weathered or massive, depth of soil layer, what is the slope of the ground, what is the seismicity of the area, 150. So if I want to go back and see which is the most important category here, which is the most important category? Environmental and receptor. These 2 guys get the highest marks. So important is the development of site sensitivity index. You can develop your own with your own group of experts, okay, both the weightages. But here, for example, here are the indices from 0 to 1, okay. If a national highway is available close by, if there is no road, that is the difference. If the distance from the city boundary or the collection, city center or the collection area is less than 10 kilometers, it's a good site. But if it is greater than 25 kilometers, it's a bad site. So like this, population within 500 meters, very less, 0 to 100 people, but more than 1,000 people. So this is the low end. So suppose I have 50, then I'll give 0.125. Got it? So like this, we are able to, using this, use of site by nearby residents not used. Somebody is regularly coming and doing yoga there. So, you know, that's an issue. Distance to the nearest building, 3 kilometers, less than 500. Land use, Completely remote, degraded, not being used, residential. Decrease in property value with distance. So how does the decrease in property value take place? And public utility on the site, is there a commercial area? Worst is airport. If you have an airport, the site is out. Public acceptability, non-acceptance is most often nowadays, but acceptance with changes and fully accepted. Like that, the indices have been made for everything. Distance to nearest surface water, if it's 8 kilometers away, fine. If it is less than 500, your landfill site has got the buffer, but it still is close to a river. So that will give it a high index. So like that. So for each one of them, for example, if the soil permeability is less than 10 to the power of minus 7 centimeters per second, good site, it's like a clay barrier. But if it is greater than 10 to the power of minus 3, bad site, it's a pervious soil. Also, if the rock is massive, it's good. If the rock is weathered, not good, like that. If it's high slope, maybe there are slope stability issues, or maybe the leachate can come out and run down the slope for very large distances, is the two issues. And of course, low seismicity area is fine, high seismicity areas are not fine. So let's take a case study to understand how this is applied. Now for each site, this is for a Bangalore site, so we are away now from the Allahabad selections. This is one site only I am doing in Bangalore. I need this measurement, right? What is the type of road nearby? A state highway. What is the distance from the collection point? 25 kilometers. This is for that particular site. What is the population within 500 meters? 100. Distance to the nearest drinking water source? 200. Site not used by residents, 100 meters away, remote, no decrease in property value, no public utility, and there are no complaints from the public. So like that, this data has been collected. It's not a critical environment. Distance to the nearest river or a pond or a lake is 1.5 kilometers. Depth to groundwater is 5 meters, and so on and so forth. The effect of the site on health is estimated as moderate. Job opportunities will be not very high. Odor will be moderate. Visibility partly seen site. Precipitation index of Bangalore and climatic features, no problem. So like this, the permeability is 10 to the power of minus 4 to 10 to the power of minus 5. Depth to bedrock 10 to 40 meters. Weathered rock 2%, zone 1. So these are the weightages. Now let us see if with this data, this is the first, I am bringing back that first slide. Let's look at 25 kilometers. What sensitivity would you give to it? And let's look at the sensitivities recommended by Central Pollution Control Board. So for 25 kilometers, what is the site sensitivity index which you will adopt? Please tell me. 0.75, because this corresponds to this and this corresponds to this. Hopefully they'll adopt that. How much was the population? Within 500 meters? 100. How much would you adopt? 0.25. And let me go to distance to nearest drinking water source, 200 meters. And here it says, he is talking of 5 kilometers. So our will fall here. So 1. So let's see. 25 kilometers, 0.75. 100 people within 500 meters, 0.25. 200 meters, 1. So now you will multiply this sensitivity index with this weightage to get this value. So if it was the worst site, it would have been 60, and if it was the best site, it would have been 0. For this site, if I add these two up, I get 35. Similarly, if I add this up, I get 87 out of 250. Okay? So a land use zoning completely remote, 0, no decrease, 0. So like that, I got the values and I multiplied them. Environmental related, you got these values, and in socio-economic related, I got these values. So here I got 205 out of 305, and here I got 36.5 out of 110, 21 months. Even that is very low by our standards, but it must have been a small site which has to be developed. We have talked about how much should be the minimum life. How many should be the minimum life of a landfill? 10 years is how many months? 120. So this is less than the critical size that we have adopted. In any case, so you are getting the values for each one of them, and in the end, when you add up all the score, you get 489.75. That's bang in the middle of the 0 to 1000 scale. We have a 0 to 1000 scale. So do you think the site is acceptable or not acceptable? Please note that these are relative ranking indices. Okay? These are relative ranking. So if you have 3 sites, then quite clearly the site with the lower score is better and the site with the higher score is not better. However, if you are treating this as an absolute value, then we have to answer the question, do we accept this site or do we not accept this site? So typically, if you were to divide the 0 to 1000 scale, you would have said, okay, not acceptable, acceptable, in between. So suppose I want to adopt the 0 to 1000 scale into 3, not acceptable, acceptable, in between. So how would you make the grouping? You could do a linear grouping. 1000 divided by 3, 0 to 333, acceptable. 330 to 666, in between. You take the call, and 666 to 1000, not acceptable. So you need a scale. But remember, site ranking methodologies are for relative comparisons. The absolute scales to withstand scrutiny are difficult. However, at least in that document of the Central Pollution Control Board, this is what is listed. Less than 300, preferred site. Take it. 300 to 750, a huge range. Moderate, left to you to decide. If you have a better site, go for it. If you don't, perhaps you have to accept this. And greater than 750, undesirable. Therefore, it would be a moderately acceptable site. Compare it with 2 other sites and take your decision. I would like to say that we have all talked of a locational criteria, and we had these municipal solid waste management rules which were revised in 2016 towards the end of last year. So now these is yet another table about the constraint mapping. Not permitted: coastal regulation zone, wetland, critical habitat, sensitive zones in the floodplain. In our table it was said, in floodplain please put an embankment all around, but it says not permitted. Now I don't know how it will work, because the Indo-Gangetic plain is a huge floodplain, so you can't say that don't make a landfill there. You might want to put a protective embankment so the flood doesn't come inside, but that's something at the moment it is not allowed. Rivers 100 meters, ponds, lakes and water bodies 200, and others non-meandering 500, habitation 500, earthquake 500, flood prone not permitted, water table 2 meters below. Airport is still 20 kilometers, because always the problem of bird hit. If you have a landfill, there will be birds. If you have birds, then they will be able to damage the aircraft. So with this, we have now understood the site methodology. Any questions on the topic of site selection? Okay, then we'll continue from here in the next class. All the best.